Hello everyone, this is Bradley. Today this is a fundamental tutorial talking about variation in instances. I've seen people being bothered for a very long time. Surprisingly, I've checked on YouTube, but I cannot find any tutorials regarding this topic. I believe it's just my oversight, because this is such a common topic that there should be a tutorial about it since 4.0, where we have repeat zone. So, as this channel isn't a popular one, I'm not going to do the popular thing that many other people potentially have done already. Before we are going to solve the problem, I'm going to talk about why your setup wasn't working and why it shouldn't. Sometimes people may not really care about the internal algorithm of how things are implemented, but I think this is a very important thing to discuss. So let's start. So here we are in Blender, and this is a very basic geometry node setup where I started with a curved circle node, and I'm using a curve to mesh with a curved circle profile to make that into a donut shape. I am also going to use a set curve radius with a random value node to make a random radius for every point. That's why you're seeing this kind of jagged geometry, which is basically a donut with different radius per point. Here I want to briefly discuss two types of socket shape within geometry nodes up to 4.0. We basically have a circular shape, and we also have a diamond shape. Within diamond shape, we have two variations, which we will discuss later. For circular shape, it's basically a constant. It's very straightforward that 1 is just 1, 2 is just 2, 3 is just 3. It's the same for every places, every context, every geometry. So it's very straightforward. But for this kind of diamond shape, it's mostly referring to things like position, ID, or index. This can be called attributes. Some people also call that fields. These two terms are used interchangeably, which I'm not going to stick with textbook definition. You just get a kind of idea, which will be fine. Okay. I've talked about these kind of nodes in capture attributes tutorial. Basically, these are based on the context that when I'm using a curved circle, then this position is outputting the position for a curved circle. But if I'm using a cube, then this position is outputting the position of a cube. How come a single node can output a different position value? This is because the position value by itself contains no data. It's actually extracting the data from this green geometry data block. That's why if you're working with a cube and you try to visualize a curved tangent, then you will only see a black cube because the data is only 0. You can also confirm that within the spreadsheet, where we only have 0 in the viewer, because the mesh is a mesh. It does not contain any data for a curve. This is also why whenever we are using a viewer to visualize this kind of diamond shape, it only makes sense when you have a geometry. Otherwise, there's nothing being shown in viewer anywhere. Okay, this value or this node only makes sense when you have a geometry. Otherwise, there is no data. As for different feeling of this kind of sockets, as you can see, there is a hollow shape, but there is also a solid shape. It only means that there is a default input into these sockets already. As you may see that there it says it's an integer field based on ID or index. It means that ID is already being input inside. If you input an ID, you can see the viewport does not change. if you input an index, the viewport does not change. This is because you basically have the same input inside. However, if you try to use the position or other values, then you can see this ID is changed. And here I also want to give you an example that if I'm inputting a circular shape into this diamond shape, because this is a constant for every geometry, every places, every point, every vertices, you can see there is basically no randomness throughout this curved circle. However, if you change the seed, of course, the random value will give a different result. Okay, so this is the difference between a constant and a field or attribute. Here we basically covered the basic concepts of random value, in which you have a default input of ID and index to set different curve radius per point, so that we are having this geometry. Next issue is that now I want to instance this geometry differently. So let's go to another node tree that I start with an arc. It's basically just a incomplete curved circle in this case. And I'm using this instance on point to instance previously the same setup of our weird donut geometry. And then you can see they are the same geometry. Right now, this setup is doing 100% of what it should. These are identical instances, and it does not cost extra performance to make variances of instances. But in many other cases and perspective, people think this is actually a wrong result. Often that people will group their instances into a group node. And I already created that as a wiggle donut geometry, and this is basically the same geometry of what we are having. And imagine that this is a flower or an explosion, a tree, a stone, a rock you created, and you input that into the instance. And people are often looking for a variation of these instances. For example, that I already made it. I want to have this kind of donut of different radius with this setup. Okay, and people simply think that oh, I put a random value, and this random value goes into the radius, and it should work, but it doesn't. And the people start to ask why it doesn't work. And even if you plug that into the ID or other things, and it does not work still. And by changing this kind of random value, you can see they are 100% identical instead of being different compared to the other setup. So why doesn't this work? The answer is quite straightforward if you look at how this setup is being built from the most beginning. And the reason that you input that into a circular socket does not work is because, as I mentioned earlier, that this value by itself has no data, and you have to have a geometry so that it can know its data. And in this particular case, there's no geometry, there's no data, and so what you're inputting is basically zero. For this curved circle node, you will find that by inputting -100 resolution, and 3 points are basically the minimal point amount you have. Whether you are inputting 0, -100, -1 billion, you're getting the same result as resolution 3 in this case. Okay, so it does not work when you are inputting value 0. And now, if you try to input that into the ID, and you can see it does not really make any sense. You are basically just stacking random values for whatever cases. It's basically dumb. And the reason that for the same ID, you are not having significant difference in radius is simply because this is a two tiny values. Every ID is basically either 0 or 1. You cannot see differences. But if you make that into 5,000, you can start to see that we have different ID and we have different radius. But of course, by just stacking with this value, it does not make any changes to the final result, because the data are all made or extracted from this curved geometry. So basically, the design of this instance on point is that whatever happened onto the instance socket is living by itself and has no relationship with the points or other geometry inputs to the points. So whatever happens is only meaningful to itself. And people may still want to argue that, oh, I heard what you said, but I just think this random value should just work in this case to generate different variances. Maybe we should come up with a method to associate with arc ID into this random value ID, whether we're using a capture attribute node or maybe we're using a sample index node. I don't care, but it should just work. The reality is that it is not, and it should not work in the way you're suggesting. One kind of problem is that we already know in regular cases we're having a different ID for every point, so that we have a random value for each point radius. But when we're instance yet, how do you know if I want identical instances or different instances? And even if it's different instances, does it mean that I want to have a different ID for every point on every instances, or I want to have the same random ID but for different instances? Okay, so there are many different possibilities that you have to define how ID functions, and it will only make the entire design more complicated. This is the same when we are talking about this capture attribute or sample index node. They basically have their own behavior when you are working the single object, and when you're instancing our object, it's very hard to define which kind of behavior you're really looking for between different possibilities. Okay, and basically, in short, what many people are suggesting in this case for this random value into this radius to work is basically to say that if 1 plus 1 equals to 3, then my setup should work. And the answer is that 1 plus 1 does not equal to 3, and it should not equal to 3. And here people may want to say that oh, I have seen other node system or softwares that can allow this kind of weird behaviors, whether it's Autodesk or Cinema 4D or whatever other stuff. And my response or my thought is basically that in order to 100% mimic this kind of behavior of a different system, we may end up rewrite the entire geometry nodes, and all tutorials up to date will be irrelevant, and it's not really beneficial to the community. It's not really beneficial to the user. It happened in the past, and I encourage that because it was beneficial, but in this case, it's not. There are textbook solutions to create instance variations, but just not the way that many people are suggesting. Okay, and the textbook solution is basically what we're going to talk about next. So here, let's talk about the textbook solution for instance variants. Basically, we're going to use the repeat zone for 4.1, and the concept is quite straightforward. That I have a wiggle donut node group, and I have another one, I change the parameter, I duplicate another one, I change the parameter, And I take a geometry to instance and join everything together and plug this collection into the instance. And now if I so now I have all this kind of collection being instanced onto every point. But if I enable this pick instance, then you can see one of these three variants will be selected for every point. So in order to have every point a different instance, I'm going to duplicate this node group for the same amount of time. And if I have 100% of points, then I have to duplicate this node group for 100 times. It is definitely dumb to do by repeating all this kind of group node and setting different parameters. There are definitely ways to improve this workflow, but it does not change the fact that we have to keep duplicating all this kind of group nodes over and over again for billion amounts of times. Okay. That's why we want to use a repeat zone to repeat this kind of tedious workflow. So let's start working with it. Let's clean up this node tree first because we no longer need all this kind of irrelevant stuff. Let's only keep this arc and repeat zone. And basically what we are going to do is that I'm going to take this group node. This can be just a group node, or it can be any actual setup being expanded, but it might be easier if you have a group node. And basically we join geometry. And the repeat zone is basically similar to simulation zone, that you input, output, and this output goes back, so that we have to keep joining a new wiggle donut every new iterations. And we are going to transform this wiggle donut into a geometry to instance, so that the end output will be a new instance. And I'm going to generate a random seed for every iteration. It's basically just a math node. We start from 0 and we add 1, and we output it, so that what will happen is that every time when we increase these iterations, then this new value will plus 1, so that they can be they can have different seed. Let's just use a random value node. For example, I'm going to change that into an integer to define different resolution. So I have minimum resolution as 3 and the maximum resolution as 15. And I plug that into an ID, and then I plug that into the resolution. Note that because we are plugging that into the ID, we are transforming this ID from diamond shape into a circular shape, because what we are working with is actually a constant value. Okay. And now you can see they are the same. This is because the iteration is not different enough. And as soon as we change this iteration, then we have different variances. And in order to match the amount of variations to the amount of points we have, I'm going to do a domain size calculation. And this is a curve, so we go to the curve. And I'm going to set the iteration matching to the point count. Then we have different variations for every point. And you can do this for all these other kind of case. For example, we have a float. We can decide different radius so that they have different radius. And you can do this kind of setup for all kind of case. I can even join a cube with different cuts in the x-axis instead. As you can see, the cubes are having different cuts on the x-axis, and so on and so forth. Okay. Here, this is just an example. In reality, it can be a tree, a flower, or a rock, or any other things for your geometry. but basically this is yet. And it's not really limited to this kind of circular socket. You can use that for this kind of random value as well, or seeds socket as well. Okay, so feel free to do whatever you want in order to make it work. And as you may see that if you want to join multiple geometries, that you either have a curve or a donut. In such a kind of case, you just join them together before geometry to instance, so that you can put them together and so on. Okay. And there are many other things that you need to do. For example, if you have multiple the same random value, you can realize that they have the same ID, they have the same seed. You may want to distinguish it in order to make a random value really random and so on. Okay. But this should be set by yourself in your free time. That's not in the scope of a tutorial today. At the end, I want to mention that this is not the ultimate solution yet, but this is the solution for 4.1. One kind of issue you need to understand is that a repeat zone means it's a serial loop. It actually means that, for example, we have a kind of node group and node group. We're joining them together in a serial way instead of a parallel way. In the outcome, they do not make any difference, but there can have some performance implication in a serial loop compared to a parallel loop, because obviously it does not make sense that my fourth instance will have to depend on how previous three looks like. So there can have some performance cost on your CPU or GPU or whatever other stuff. Okay, but we do not have this functionality yet, which is called loop for each. So in the future, if a loop for each exists, use a loop for each. But for now, we have to stick with this kind of repeat zone methods instead. I don't know how long it will take, maybe 1 year, 2 years, you never know. Another thing is that it's possible that we will finally adopt Houdini-like solution for instance variation, so that there are easier way to make instance variance. But it may take even longer time, maybe 10 years, 20 years, you never know. At last, I want to mention that I'm using this wiggle donuts example in this tutorial just as an example. In reality, if you want to achieve a certain kind of results, obviously you are not going to use repeat zone. You can use some simpler methods, but this repeat zone method should be universal for every kind of instances and any kind of cases where you want instance variation. This is basically the golden textbook methods that you should follow if you aren't sure about other alternative methods. Okay, so basically this is it. I hope you enjoyed this tutorial. I'll probably see you next time. Bye bye.